lunch, and I apologize because I know how serious lunch is. So this time, if any one of the fellows or any one of the students wants to wave their hands when I'm at like 20 minutes, wave their hands even more when I'm at 5 minutes, throw things at 1 minute. Don't throw things at 1 minute if I seem like I'm wrapping up. I threw together this slide thing quickly because I didn't like the slides that we had. And this is going to be like a little background stuff, but I really want to spend as much time as I can just doing React and walking through it slowly. But this right here is just to talk about where we've been. So where have we been? Well, we started out with a static HTML server. That's like the most basic idea of what a web server can be. So it serves up static pages that may be linked to one another because that's how HTML works. So we have these 3 clients. Most of the people who use the internet are monkeys. And they can make requests to a server, and that server will respond with some sort of HTML. So here's a GET request. Return some HTML. I spent so long making this for how you just go through them like that. Boy, PowerPoint. And we return some basic HTML page, and there might be a link in it to another web page because HTML lets you link to any page. But you might link to another page that happens to be on your server. And so when you use /subpage, that is going to launch another request to your server, returns a brand new HTML page, and now we're at a brand new page. And in the static HTML server model, every single page you're serving up is a separate resource. Every HTML page is just a different page. And that quickly gets annoying, especially if you want to do the whole don't repeat yourself principle. So pretty soon after standard HTML web pages started appearing, this idea of HTML templating started appearing. And basically, it just says that on the server side, you're still going to be sending over a single HTML page, but you're going to have this sort of pseudo language. We use Nunjucks. There's lots of others like Handlebars or Mustache. They're all very similar in that they let you take data and HTML and combine them with things like conditionals and loops, so you don't have to, well, it's like a way that you can repeat stuff in your HTML to match what your data looks like. So it's a way of tying data to your HTML. And at the same time, we got RESTful endpoints, which is this idea that our server is going to have a database, and that database is going to be able to be updated. And when we combine our data with our HTML template, we want our HTML to like reflect what the state of the data is. So we might have this. We have a server and a database. They might be the same computer. They might be different computers, but they're able to talk to each other. But there's this like big line here that makes the backend. So even though I didn't draw it, over here is this big line that's the backend. So the server can talk to the database, but the client definitely can't. So the client sends a GET request, goes to the server. Now we're on the server. Server maybe fetches some data, grabs an HTML template, combines them, still produces a normal HTML template that they're ready to send back. And they send it back, and from the client side, they don't notice any difference. If the client later, clicks something and you have a callback on your front end that says, OK, now we're going to do a post request. Well, on the back end, you would receive that post request, you would update the database, and now that the database is updated, you would, send back maybe the same HTML page, but now, different data plus that HTML template means that it's going to be reflected in the HTML page. But it's still going to be a reload. So just like in Craigslist or something, every time you are going to click something, anytime something changes, it goes all the way back to the server, it makes that change, and then it sends you back a brand new HTML page. And that actually can get you pretty far. That's enough for Google. That's enough for any news site. It's enough for sort of any site that doesn't have the best user interface, but it can sort of do anything. Like I've used things that are web app-like from this era. Microsoft has a lot of internal web apps that are terrible because they're internal. So the thing to reserve your seat on the bus was this terrible website where like for every day you wanted to reserve your seat, you like clicked on the day. It reloaded the page to show you the times. You clicked on the times. It reloaded the page to be like, okay, well now you can say, yes, I want this, and then it would like reload and it would show you on the calendar you did reserve that or you didn't reserve that. But it was so frustrating because what you wanted to do was say, for the next 4 weeks, I want to reserve a bus seat at 9 a.m. And that would take so many steps, and it was very frustrating. And someone made some automated thing that would like click for you. But that's not, like really they should just make a new website. Yeah. That's the problem with internal things. If you ever work on an internal thing, no one cares. They're like, oh, it's really ugly and hard to use. Well, only our company uses it, so why should we fix that? Yeah. So around 1995, we introduced JavaScript. Over time, between 1995 and 2005, jQuery gets introduced, and JavaScript originally is just to animate things. You now can have games by, on the front end, removing things from the HTML and putting it back in, and you can, change what the page looks like, and that gives you animations, that can give you games to some extent. Lots of websites still work this way, where they are primarily static pages that, serve up a page, has some JavaScript on it, and that JavaScript is running client side, and in response to various things, it will, replace something on the screen, or animate something, or hide something with CSS. And that works great, but something that still doesn't get you is like, what if you want to have some basic app, what we call a CRUD app, create, read, update, destroy. So your app represents some database, and you are interacting with that database. You want to add things to it, you want to remove things. So we have like a list of movies, let's say. And you want to add movies, remove movies, and you'll be doing that. You'll be like changing how that looks on the client side maybe. But if you want that state to persist on the server, you're going to have to send some post request, and only once that server updates will it respond to you and reload the page. So while JavaScript and jQuery let you update what the client-side page looks like, there's still this issue where you're going to have a page reload and send a brand new request if you want to update what something looks like on the server. And really what we care about at the end of the day is something like persistence. So if I'm on Amazon.com and I start adding things to my cart, it might show that it's adding things to my cart on my page, and that might be enough, but what if I close the page and then go back to it later? Everything in my cart will be gone. And that's why in an old version of something like Amazon, I'd have to click like, save to cart, and that would now go back to the Amazon server, say they're trying to add all of these items to their cart, and then it would send it back and refresh and say successfully added to your cart, now continue shopping. But that's not what we want, and Amazon has this stuff now where it's a lot more fluid. Every time you click something, you see it update immediately, doesn't have to do this reload, and that's because of Ajax. So how is everyone feeling about Ajax? We kind of introduced it very fast, and it's like a big idea that changes things. So I will say you'll see more of it, because now that we hit Ajax, we don't look back. So Ajax lets us, just like before, someone's going to make a GET request. We serve back HTML, and it might have some JavaScript in it. But now that JavaScript can't just change things on the page, it can also send non-blocking requests back to your server or to another server. That means someone can continue using your app, but they just sent a request, just like a RESTful request to your server. And instead of responding with a brand new page, it will respond with JSON or maybe like an HTML snippet. And you'll have some callback function on your front end that will be able to automatically take things out and put things back in the page to reflect that you just received data. So now we can serve something up from our server to our client, but our client can continue to interact with the server, and it seems seamless from their end. That every time there's some update, they can click something, it actually sends that request to add something to the cart. That request is successful, so something is sent back to the front end, and then the front end updates to show, yes, something was added. And now you might see like, a little circle saying like it's processing. But you can still scroll up and down. You can click more things. And it's a much more fluid UI experience. Yeah, and Ajax is what allowed for things like for things like Gmail. So before Ajax, you really couldn't have an application-like experience. So you had applications like on your phone or on your computer, but the kind of interaction we think about with applications where you have lots of buttons and every time you click something, things automatically update, that wasn't really easy on the web because the web was just for static pages. But Ajax allowed you to change those pages in real time so that it looks, even though it's still just a static page, it looks like it's a live display that's updating. And that's great. It allows you to build things like Gmail, and jQuery added a bunch of Ajax things. And stuff like Gmail doesn't even use jQuery. It's pure vanilla JavaScript. And that's what we call buzzword Web 2.0. So Web 2.0 is the introduction of Ajax. When people say, if anyone says something's Web 3.0, I don't know. The idea is like, it was a big deal. It's a big deal because now the web is fundamentally different. It's not just serving up static pages. It's not a reload every time you click a button that is supposed to update something. Your web page is sort of like your screen, but it's seamlessly interacting with any number of servers that are not on your computer. And we might model it more like this. So we have our server, we have our client, and as time continues, this first one is going to be a request for the page, and that page returns. But this next one might be like, oh, I clicked add movie to database, and it responded, movie successfully added, now I'm placing it on the page, so you see your UI reflect that something changed. And this more or less works. This is great. There are problems with it, though. As things grow, especially if you're using something like jQuery, you might have noticed this when using jQuery for Trip Planner. You have your data, and your data lives on your backend. But whenever you get like some Ajax back, you're going to update your data that exists on your client side. And you're also going to update your view. You're going to update what your HTML actually looks like. And so you have like your true model, which is the server side, the backend, the database. You have your client side model, which is your client side being more or less synced with what the data should look like on the back end, but if there's an error, maybe it'll be out of sync. And then you have your view, which is how the HTML should look in response to the data. And none of those things are implicitly tied to each other. You have to do all of this busy work of saying like, okay, I sent my Ajax request, I got back new data. Let me add that data to what I currently have, but let me also add something to the page or remove something to the page. And it gets confusing very fast because you're still thinking of it as a static HTML page. And yeah, the bigger a website gets, the more you have these pieces, and you might not want each page to be entirely separate. Templating isn't enough. You want to have this more like component-based model in which you build things up from pieces. So let's say I'm on Facebook. And Facebook is a really good example in this case, even though I use it all the time, because they made React for this purpose. So it's very hard to think of this as an entire page. How's that? Some bar mitzvah maybe or something? I don't know. A wedding? Not a bar mitzvah. I'm way too, I don't know how I thought that. Yeah. Yeah, so take something like this panel on the side here that makes up the chat thing. There's so much information just for that one thing. And it would be so hard to think of this whole page as a single page, even though technically it is. What Ajax lets you do is that you send back one page, and that page runs a script that then continues to talk back to your server to update data, and then when the data changes, update what your page looks like. So we call that a single page application. It works a lot more like an application. Just about everything, you might not even have to, I don't even have to reload to see new content. I could just keep scrolling down, and that sets off an Ajax request. And let's say I go into, oops, how do I do this? Let's say I go into the console here, So first, lots of block things, probably because of my ad blocker. It's funny that they write that, just in case you don't know. So if I look at my network here, why don't I see nothing? Hello, where's all my stuff? Okay, so like I'm going to scroll all the way down, and you'll see I just made a bunch more requests for things. And it made lots of requests for images and probably for data. And knowing something like Facebook, it's large enough that it's talking to lots of different servers. There's lots that could be going on. But it all seems seamless, like I never left the initial page. Let's X this out. But yeah, Facebook wants to do things in this more, not Facebook, single page applications. You want to do things in this more component-based model because, one, the bigger things get, the more you want to be able to compartmentalize and say, well, this big chat thing over here, it's actually made of individual people who look like this. And so I want to say what an individual part of, it's so big. I want to say what an individual part of this HTML looks like. And then even that I can break down more. It has an image, it has a text field, it has this circular green dot, whether they're there. And there's this idea that you want to be able to define everything in these small pieces, say exactly what data that individual piece relies on, and then you can build up larger things based on those small pieces. You might notice at the same time, though, there's lots of times where information is shared throughout the app. So this tells me how many notifications I have, and I can't see anything here right now, but there's lots of places where data can be seen twice. So I don't know that I can see a good example here, but yeah, for instance, if I were to click here, it would tell me that I'm in a conversation with these two people, but that's also reflected here. And ideally, those should be referencing the same data. We shouldn't have to have a bit of data that says, I'm speaking to my friend Kyle, and a bit of data here that also says I'm speaking to my friend Kyle, and that they're two separate bits of data that are separately being maintained, because that becomes a maintenance nightmare really fast, where every time you want to update a bit of data, if 20 things rely on it, all 20 things need to find out about it. And if the update came from here, this component needs to communicate with this component. If the update came from here, this component needs to update this component. And I might have gotten a little ahead of myself, but that is sort of the problem with Angular. Serious software is serious. I don't know who wrote that. I don't talk that way. Should be easily understood. Easily maintained is by far the most important one, because there always comes a point where stuff gets large enough that no one knows what's happening. Basically, you make a change, and it's like a snowball effect. That change creates changes, creates changes, creates changes, that whenever you do something, it can be hard to know, what else it's doing. And when you have a bug, it can be hard to find out, well, who touched this? And it might have been lots and lots and lots of, different components. It should scale, it should work, yeah, so in response to the fact that jQuery was not suitable for making these large single-page applications, lots of companies started inventing these different libraries and frameworks to help you solve this single-page application problem. I should probably say here the distinction between library and framework, because I didn't know it for a long time, and it's very helpful. So you can think of a library as being it's like a toolbox of functions. Like a library is something that you can opt in, where you say, I want to use Lodash maybe, but I only want to use this one function from Lodash, and that's all I need to use. And if I want to use another, I can use another. And it's really just someone having written functions for you, but you're still going to write all the code that uses those functions. So you are still the writer of main.js, but you can use these various tools that have been provided for you in a library. A framework is a little different. A framework is the idea that somebody wrote a lot of code for you, they're starting the application, but you're going to write pieces that fit into it. So the framework creator says, this is a really complicated problem, and there's too many individual pieces for you to handle. Wouldn't you rather forget about boilerplate, not have to write so much to do so little? We're going to do a lot of that work for you. And the classic example is something like a game engine. So if you want to make a game, really what you want to do is take some idea you have and display it as a 2D or 3D image. And there's lots of things that are standard to games that you take for granted if you want to make a game, but you forget, like, oh, right, there's no concept of gravity. I need to create that. And if I want any physics to happen, if I want things to collide and not pass through each other, I need to create that. And there's all of these problems you'd have to solve again and again and again for everyone that's making a video game, because a lot of people who make video games want this idea that there's such a thing as the floor, and you don't fall through it. And that's not necessarily how images work. If you put one image here and one image here, well, if you don't have gravity, they're not going to move. If you have gravity, this will fall. So you need gravity, and you need this idea of like a collision mesh where you say, this can't pass through this, but maybe something else can pass through that. And like, there's all this complicated logic that the average game developer doesn't want to have to think about. The average game developer doesn't want to have to create a graphics library from scratch. They just want to use all these features someone built and make, their own Mario clone that just like, makes the gravity a little lower so Mario jumps higher. And that is what a framework's for. And there are times where frameworks make sense. But I will tell you that Angular is a classic example of, well, one, why frameworks are terrible, because frameworks are like a car salesman, they say, this is too complicated for you. Don't worry, we've figured everything out. It's going to be really simple. They show you the perfect example of when it is simple. And then you're like, great, I'll buy into that. You buy into it, you start using it. Eventually, you hit a problem that they didn't anticipate. And they're like, oh, no problem. All you need to do is now learn how Angular works. And that's a 100,000-line JavaScript file. So it goes to show you the problem with not just running code that you didn't write, but relying on this massive system that you didn't write. So it's not just like you're using a function that takes some input, returns some output. You're running your code in some environment where there's all this stuff going on, and it's very hard. Like, it's the worst thing in the world. Angular plays this trick on you where they say it's going to be really easy, and it is really nice for prototyping. You're 3 months in, and you're like, Angular's great. And then something is not possible that you want to do how Angular expects you to do it, and you have to start learning about, like, $$ scope, and you're never supposed to touch things that look like this, and things called transclusion, and like these other, this is the other thing about Angular that I'm just happy we don't have to teach it. I'm very happy, because I had to relearn it when I got here, because I switched to React, and I'm like, I'm happy. Did Angular for like 2 years, 1 month of React. I know you're not going to have this experience yourself, but 1 month of React will convince you this solves all of those problems, and how annoying that Google convinced all these business people, because of their Google name, to say, like, basically the argument of Angular is saying, boy, this is really complicated. It must be really complicated because it has to be, right? We're Google. We couldn't make something bad. We must have made something only for really smart people, so you need to be really smart to understand it. And in reality, no, it's incredibly over-engineered, very complicated. They use words like transclusion, which is some mathematical term, and when you learn what it means, you're like, oh man, why did you hide a very simple idea behind a very strange wording and all of, like, it's just, they try and get so abstract. Was anyone here Angular people? No, you guys were React. Kate remembers the good old days. The most common question on Stack Overflow about Angular is, what's the difference between a factory and a service? And the answer is, well, they're both, wait, what is it? They're both, in my opinion, basically they made like 4 or 5 things that the answer was, oh, they're all the same thing, they're just slightly different, and we call them different things so that people could write thousands of articles saying when to use X and when to use Y. And it's like, there should only have been one. You're psychos. Angular, it's so good that we don't have to use Angular. Angular 2 is not taking off because everyone learned their lesson. And like all the good things about Angular 2 are trying to play catch up with React, and even if you like the Angular 2 way of doing things, and there are advantages to it, there's this new thing called Vue.js, which is like Angular. It's very similar to Angular, but it just doesn't make it that you have to take this massive thing at once. You can pick and choose, and that makes it a lot nicer. Because Angular is very much like learning Angular. You're not learning more JavaScript. You're learning Angular. It's such a unique pseudo language. I actually want to show you some of it. So when you do Angular, you sort of have like your HTML has extra things like ng app. So ng means Angular because ng apparently sounds like Angular. And that should be your warning sign that they are not friendly, that they have not thought this through and they're too in their own heads. Right. So they will have something like this where they say form, ng submit, ng model, new to do. And I don't know that I can find it here, but right, new to do. And then here I'm going to have like some JavaScript where I say controller, to do controller, scope.new to do. And then I have like this idea of two-way data binding. So this is an input, right? And I could type into that input. And normally with jQuery, you'd have to say like, maybe when the user hits enter or every time they type a letter, you're going to want to check what's in that input and maybe update something in your code that you have in some sort of, variable like this. Whereas in Angular, we have this idea of two-way data binding, which says, I have this thing here called ng model new to do, and somewhere here I've said that this is the controller I'm associating with this HTML page. So I've said that this HTML and this JavaScript are like inherently bound to each other, and they have a two-way binding. So what that means is that right here, new to do is nothing. It's an empty string. So when this first loads, this input will be empty. But if I start typing into this input, that is automatically going to update what new to do equals here. And if then I like click a button that sends some AJAX request, so much. It's going to send some AJAX request. Well, it can just use this to-do variable because anything I've typed into here is automatically updated here. And anytime there's a change here, it's automatically updated here. So the point there is that you still have your HTML, you have your JavaScript, but if there's an update in the HTML, it automatically is reflected in the JavaScript. And if there's an update in the JavaScript, it's automatically reflected in the HTML. And it's because you have like a variable that you share with it, and they are bound to each other. It's kind of similar to Nunjux, but Nunjux is a one-way function. You give it some data, and it produces something and outputs it. Whereas in this case, we're giving it some data, but every time there's an update on the HTML that's associated with that data, the data in the JavaScript also updates. Does that sound confusing? Does that make some sense why you might want that? Yeah, basically we just say like, I have a variable that's going to represent that input string, and I'm going to display it over here. But if at any time it's changed over here, it's automatically going to be updated here for whatever purpose I want. And let's say I happen to like call some function that replaces what new to do is or updates it, it's automatically going to be reflected here, so you don't sort of have to do that busy work. It's called two-way data binding, and it very much is magic. And the more you program, the more you will learn that magic is not good. If you don't understand what's happening, it means they're hiding details, and eventually you might have to know. And it turns out that magic is really complicated, and you're going to get an error when you run your code, and that error is not going to be in your code, line 56. It's going to be in AngularJS, line 4872, and you're not going to read all that. And so you're just going to at some point say like, I only sort of understand how my code is running. And there's all this bullshit, just like scope.$watch. It was bad. It was good when that's all. Honestly, there's worse things. It's better than jQuery for sure. But there are problems with it, and the main problem is that it follows this model that worked for front ends on like standard applications on your computer or on your phone. And there's this thing called MVC, Model View Controller. So Angular is there on the right. That's Angular. Backbone and Ember are two different libraries that together can do what Angular does. So the only difference is that Angular is like one monolithic framework. It does everything. Whereas Ember and Backbone are more like React in that they are libraries that each do a piece of the puzzle, and you have to hook them up. So just like you have Express and you have Sequelize, and you have to use them together to actually accomplish what you want, similar with Ember and Backbone. And even like today, we're going to be talking about React, but we will eventually be talking about this thing called Redux. And React, probably the hardest thing about it is that it's hard to see its value until you've put all the pieces together. And I'm sure there's going to be some frustration where you're like, we learned how to do it this one way, and now tomorrow we're like adding something new and not doing it that way. But you'll see that React is powerful. It can do a lot of things, but it's kind of at its most powerful when you only let it do a very narrow job and let some other tool do another job. Very vague. Yes, so this is the ultimate problem with the MVC pattern. We have all of these different components, and they all have, oh yeah, I should explain what Model View Controller is. So that's on this next slide. We have our model. Our model is like our database. Our database might exist on the back end, but then we will have our model on the front end also that's supposed to like sync with the database. It's supposed to be a JavaScript object that represents the state of your application, the state of your database as far as the page you're on is concerned. And every time the model updates, if there's an update to the model, maybe from the back end or maybe from this controller, you notify the controller. We'll get to the controller. Now the view. The view is your HTML. It's your front end. Your view is the actual view layer that is what the visual information on the page is. So the idea here is that your controller ties the two together. So every time there's a user action in the view, the controller gets notified. Every time the controller can update the view whenever it wants. Every time there's a change in the model, the controller is notified, and the controller can update the model whenever it wants. And the controller is there to say, there's the view here, there's the model here. They can't talk directly to each other, but I can talk to both of them, so I'm that level of indirection to control the two of them. So it's just about making sure that your data and your view, which ultimately should be stupid, like your view just reflects data. Something I like about React is you want to think about your view as being a one-way function where, much like Nunjucks, it takes some data, it returns some HTML. And there's no further action. It's that data plus view equals updated view. So your view should be dumb. Your model just represents your data, and you want to be very specific about every time it's updated. And then your controller is handling all of the logic. So what's the problem here? The problem here is that the larger things get, the more you have controllers talking to controllers. Siblings have to talk to siblings. Think about it this way. If I design something right, I might have a parent, and that parent has access to some data, and these two children rely on that data. And every time the parent updates the model, it can update the controller of the two children, and that will update their model and their view. What happens if there's an update here that I need to have reflected here? Well, one option is that I speak back to my parent and say, you inform all other children to do this. And that works, but that's a level of indirection. Another is that I speak directly. And you can get into really complicated situations, especially if you built something and then as you kept going, you realize oh, we didn't necessarily design our hierarchy in the right way. And data can live in lots of places, and it's when something all the way down here updates, we need to update something here, here, and here. And yeah.
Trying to understand the bigger idea. Why would we want to have multiple controllers?
For subpages. So the idea is let's say I'm on Facebook and I have the chat part of the page, right? So this might represent the whole chat part of the page, and this is the parent chat part. And the parent chat part has children.
And those children are the individual slots that represent an individual person with their name and their face and a dot saying whether they're there. And if you click on them, you start a chat with them. But you want to turn things into these smaller components because ideally, if I'm doing the chat thing, the model for the chat thing should only have to know about what it needs to know about for the chat. Like Facebook is dealing with so much data, there's no way that it could take all of the data and have it in this, basically it's not a good idea for everything to have access to all data. Just like when you have the module pattern and you try and limit who has access to what, it's because if I have a problem here, I want to know where that problem came from. And it would be really nice if I just had to check here and here. But the problem with this and this and this and that turns into a massive hierarchy is if I have a problem here, I don't just have to worry about the component itself. I have to worry about everyone who talks to this component and maybe everyone the component talks to. And it just gets out of hand really fast, which is what where is it? Where'd it go? Yeah, there we go. Yeah, so you'll see the word like factory in there. That's a Angular thing. But this happens with front-end. This happens with applications on your computer too, where just the idea that you have your view, you have your data, and then something has to coordinate the two. Depending on how you set it up, things can get complicated very fast where, all sorts of things rely on each other for data. When something updates one thing, maybe that thing is going to have to update something else, which is going to have to update something else. You run into these patterns where a lot of times to make sure that everything is notified, you just send a message to the very root parent where you say, like, notify everyone this change happened. And the bigger your hierarchy, the more that could take a really long time. And in Angular, that was one of the big problems, that like the best approach a lot of the times was just to say reload everything anytime there's a change. And a big problem of that was this two-way data binding stuff. So yeah, we see it keeps growing. Here we have a var unread message counts function on new message. We're going to do something when there's a new message. And we have this little box here which has the 1 on it. But that 1 actually could appear in lots and lots of places on the page. I mean, this is an exaggeration. It doesn't appear in this many places on any page. But it's just this sort of idea that we want our data and our view to be separate. And in this situation, I might imagine that each one of these components, because they live somewhere else on the page, they are not sharing the same data. Instead, when I update one, I have to send a message to the other, oh, he clicked on it, so now you should get rid of your red one also. And vice versa, and you just end up with lots of logic to deal with how to update other things that are sharing the same data, but you're never explicit about like the fact that basically everyone is sharing data, but you don't have some abstraction to deal with that. So now we're going to talk about React, and I made sure to leave a lot of time just so we could do it live, because I think we'll understand this better by talking about it. Cool. So the big thing we want to talk about with React is this idea of one-way data binding. So in React, the view is as dumb as it can be. The view is never going to update the code, like the logic. Instead, it's always going to trickle down from the model. So the one thing to remember in React is it's data first, as in you have your model, you have your data, and any time there's a change in the data, your view automatically reacts to that change to reflect it. So like data is king in the world of React, and your view should be as stupid as possible in that it just is notified there's a change it's notified there's a change in some data it relies on, and it automatically refreshes to represent that there is that change. OK, so I have a list here of things I'm going to try and cover, and in what order. Cool. So I'm going to make a directory here called React demo. Nope. Yeah, I can. Cool. Can you guys see this? Go to React demo. And one thing that makes learning React hard
is that at this point, if you look online, people are going to tell you, like, you're going to search for, let's even try it. I'm going to search for React. Let's see how many other buzzwords we hear that aren't React. And this is kind of the biggest problem with learning a lot of programming on your own at this point. What? Don't talk to me about Wayne Brady. No, that's not his name. I always call him Wayne Brady. It's Tom Brady. Shows you where my interests are. Has anyone seen Kinky Boots with Wayne Brady? That was like the best acting job I've ever seen in my life. So, I'm not maligning Wayne Brady. Oh, saying he's like Tom Brady. Yes, screw Tom Brady. I don't even know. Oh, Patriots won. I heard about this, right? Okay, so if I Google React, I'm seeing a lot of just React stuff. But what other words are you going to see? We're going to see, let me just open this up, code dot. Taking a little longer to open than I would expect. Blue? Nope. Okay. All right. Why don't we make a file like index.html just so it knows something's up? There we go. Cool. And I'll make this as large as it can. So scratch.md. Just going to write some stuff. Right, so you might hear about React. And React is a view layer library made by Facebook. And an interesting thing about React and all of the development stuff that Facebook makes is that unlike Google, so Google makes Angular, very few of Google's important products rely on Angular. Exactly, the point is Google's a really big company. Some part of the company made Angular, and then various teams in that company either decided to buy into Angular or say, no, we have different needs, we don't need it. Facebook, it's different. Facebook is making one product. I mean, I guess they're making more at this point, but every tool they make, they use internally for a really long time and try and perfect it as much as possible. And then by the time they give it away to the world, it's like, proven to work for a Facebook level thing. So Facebook made React. All of Facebook uses React. Facebook made this thing called React Native, which is like for using the same React pattern but to do iOS applications or Android applications. And that is also like everything besides their flagship Facebook one, which is just older, that it was made in standard iOS, uses React Native. And it's like their way of saying, like, we're beta testing it for you, because if like Facebook feels confident running their stuff on it, you can be confident too. Worth noting here that if you care a lot about owning your own ideas, some people are very wary about the fact that React and other Facebook development tools have like a sort of wishy-washy, license, where it's like, technically, Facebook can at any time be like, we own that. So like, no, they haven't done it yet, but people who are like entrepreneurs and are very like paranoid or like will not use it. Just if you care enough, there's something called Preact. Oh, oops. Someone made something called Preact, which is, it's identical to React, but on an open license. So like you can get around this problem. Yeah, React is this view layer. There's this thing called Flux you might hear about. Flux is a unidirectional data flow architecture. So unlike MVC and the way Angular does things, your model and your view cannot both talk to this controller. Instead, you just sort of have this one-way thing where you have your model, which produces a view, and then anytime you like launch an update from the view to the model, it goes all the way back here and then trickles down. You updated the model, and now it trickles down to be an update to the view. So Flux is this pattern that Facebook invented for using React, and actually React is you only see its real power when you use a Flux architecture. But the ideas are separate because they wanted to make sure, like, well, you can use this however you want, but we happen to use it in a particular way. There's something called Redux that we're going to be using. Redux is a specific implementation of Flux that
I love. Essentially, Redux was made by someone who works on the React team at Facebook, and it's a simplification of Flux that Facebook themselves can't use because their problem is too big. Like, they're talking to lots and lots of servers, lots and lots of databases. But if you're always going to be talking to like one database and one server, Redux works great. And honestly, Redux works great in general. I just think it simplifies the whole Flux thing a lot. What else? You maybe have heard of JSX. JSX is a HTML-like language for writing React components within JavaScript. So React is actually written entirely in JavaScript, and it leverages your JavaScript knowledge. So you write very little HTML once you're writing React, and everything you do is done in these JavaScript files. But you have to write sort of HTML inline inside your JavaScript, and that could be ugly to do as a string. So if I write something like in my code, h1, blah, 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 that's okay, but the bigger it gets, the harder it is to work with this. And there's something nice about just being able to put something directly like this in your code, especially once you have, I mean, this makes no sense, but like I'm putting a div in here, whatever, putting a paragraph. Like, the more nested you want things to be, the more treating it like a string is not so nice, and it's nice to use this JSX thing. So JSX is an HTML-like language. So you might say, it allows you to write HTML-like stuff in your JavaScript. But what that means is that what you're writing ends up not being actual JavaScript. So that's a problem because your front end is only going to be able to run actual JavaScript. So what do we do? Well, we use something like Babel, which is a transpiler. So transpiler is like a compiler. A compiler is high-level source code to low-level machine code. Maybe it's not machine code. Maybe it's what do you call it? Well, when I say machine code, I mean assembly, but same deal, yeah. It might be something like bytecode, which is like something like Java, or even JavaScript is just-in-time compiled, which means like you might be translating it to a pretty low language that is then eventually converted down to what the machine can do. But a transpiler is the idea that you're going from high-level source code. Oops. So let's copy-paste this. Transpiler. And I guess I will share these definitions. I didn't expect I was going to talk that much about definitions, but I forgot, like, there's all these phrases, and if you just hear them floating around, you're like, why are there so many phrases? A transpiler is high-level source code to another high-level language. So essentially, it's going to take JavaScript, it's going to take JavaScript with your JSX and turn it into normal JavaScript. And there's other transpilation steps that you can take and that people were taking, not just because of React, but because people wanted to use ES6 a lot earlier than it was ready. So another thing Babel supports, its main thing, is going from ES6 to ES5. So instead of waiting for, features to be added to the browser you're using, instead, what you would do is, on your backend, you take your JavaScript written in ES6, you run it through Babel, which is going to output ES5. It's going to work as if you had all those higher-level ES6 features, but what it's actually producing is code that is backwards compatible maybe to like ES3 or something. So it's solving the problem that's existed for a long time of, if you want backwards compatibility on really old browsers, you have to add in all this extra stuff, what are sometimes called shims. It's this idea that, like, well, array.isArray might exist in ES5, but it doesn't exist in ES3. So you'd have a part of your code that would say, if they're running a version earlier than ES5, we want to define this function on the array object. And you just have all this like extra work you have to do. And Babel is a project that is supposed to do all this for you, and it's great. But we actually don't use Babel alone. We use this thing called Webpack with it. So what is Webpack? Webpack technically is a module bundler. What that means is it takes all your, takes an entry file, reads all the modules that are required recursively, creates single JS file with all the code in the right order. So remember when you were doing Trip Planner and you had all these individual JavaScript files and you had to make sure you added them in the right order. And you also just didn't have this idea of modules on the front end. So Webpack is supposed to take care of that. If there's one complaint, and what Webpack gives you is the idea of having those ES6 modules, or you can use require, but now you suddenly have modules again. And it's also going to turn all of your code into a single JavaScript file. So instead of like having to serve up, one file and then you make another request, your client receives another file, makes another request. Instead of serving up lots of individual files, you just serve up one big file, which might be better, might be worse, but it certainly makes your code a lot more maintainable. And if there's one complaint about Webpack is that it is so big, it does a lot more than what I talked about. Webpack has taken over for a tool like Grunt or Gulp, if you've heard of those, as being like a general purpose task runner. So a lot of times we use NPM as a task runner where, we say NPM start, and that actually is just calling some line of code. Or we say NPM test, and that runs Mocha and does this and that. And Webpack can be made to do all of this and more. If you want to get really hardcore in Webpack, basically you can do everything you need to do to take your code from the way you want to write it in your development environment to the way you want it to be served up to the client. So let's say you want to do like uglifying and minifying and these various things to so minifying makes your code a lot shorter by replacing every variable with like single letter variables. Uglifying makes your code a lot uglier, so anyone trying to read it will be like, ugh, and just won't read your code, because yeah, that's really annoying. And you'll notice that if you go to lots and lots of websites, like if you look at what the JavaScript they actually serve up is, it won't look something like this. It'll look more like, so if I go into my docs here, there's got to be some JavaScript. Where are we going to find some JavaScript that they served us? Anyone? JavaScript? Everything's like weirdly randomized. Nope. If I go to the very top here, I imagine in the head there's going to be a certain amount of JavaScript, lots of CSS. Here's some JavaScript. So let's actually see if we put this in, what JavaScript comes out. And yeah, it's relatively ugly, right? This doesn't look minified necessarily. No, maybe it is. Yeah, so you see it's minified because like instead of having a, what? What was that? Zoom in, right. Yeah, of course. Yeah, basically like we have function A takes arguments B, C, D, E, F, G. So it's just been automatically made. And you'll see when we use Webpack, like what it outputs is pretty hard to read, but the goal is you never have to read it. You just write in your source code, and you trust Webpack did their job. It's one of the hard things about modern programming. You have to trust lots of people did their job. Yeah, partially. Yeah, it's also done just to make it smaller. All right, we have Webpack here. Is there anything else I haven't mentioned that you've heard and you've been like, what's that? Anyone? Any idea that's not on this list yet? If not,